Hi and welcome to another very exciting tutorial. Today we are going to create an awesome Sprite Kit game which is pretty much like Mega Jump, and I'd like to give you a quick demo. So I'm pressing on start, and as you can see my figure is moving upwards, and I'm controlling it by tilting my iPhone to the left and right, and now I lost. So this is my my end game screen where we can see the points that we collected, and I have been better at this. As you can see, my high score is definitely higher than that. So let's do that one more time. So I'm moving upwards using these flowers to get boosts, and those two different kinds of flowers give different amounts of points. And as you can also see, there are bricks that break together like this, and there are bricks that we can use multiple times, and we're going to move upwards and upwards. And as you can also see, there are some clouds in the midground, and we have a nice looking background here, and continue to move upwards, and so on and so on and so on. So once we've reached the top, we end the game, and there is our high score. Alright, so this is what we are going to create, but before we get started, I'd like to thank you for another year of support on this channel. And as a gift, I'd like to give away all of my Udemy courses for free 10 times, and they're worth over $400. So all you need to do to get those courses for free is write a comment below and tell me what you'd like to see on this channel next year. I will then randomly select 10 people and send them direct messages with the promo codes for these courses. So one of these courses is also only a few days old, so for those of you who didn't get all the courses for free, there's also a link in the video description that lets you get this course for just $20. And here's a little trailer so that you know what you can sign up for. Welcome to this course in which you will create a fully customized iOS 9 application called Quotes to Go from start to finish. Quotes to Go was specifically created to work as an example for this course, but has already been downloaded from the App Store by thousands of people around the world. So this is not just a simple demo application, you're going to create a 100% real-world app. In this course, you're going to learn how to translate a UI design into a working application and how to identify and solve problems that will come up along the way. You will also learn about data-saving techniques like core data andplists to store user-generated content in an efficient way. Since we want Quotes to Go to have a rich user experience, we will also cover topics like custom view controller transitions, how to build and animate custom menus, or how to generate beautiful dynamic images at runtime that can be shared with your friends. But we will not only focus on design aspects, we will also talk about more technical stuff like iCloud integration, sharing content, but also asynchronous programming. So have fun experiencing this process and become a professional iOS developer. So now let's start creating this game. When you download the course files or the tutorial files in the video description below, you will get a folder with some game data, which includes all of the assets like the cloud, the platforms or the bricks, the player, and the flowers and the start button, and you will also get the background. So this is the complete background, and we have divided this into several sections so that we can position it on every screen size correctly. And you will also find a plist which includes all of the level data. So when we have a look at this, you can see that it's pretty straightforward. You have this plist where we have the end of level key, for example, which is at 7,200 pixels. So this is where our level ends. We have different patterns for our flowers, like circles or a diamond. And then we also have the positions for those flowers, and the same thing applies to the platforms. So these are the course files that we are going to, or the tutorial files that we are going to use. And since someone has asked how I get the iPhone or the simulator having the iPhone around it, so the iPhone itself, actually this isn't a simulator, this is the Reflector 2 app, which lets you transform your Mac into kind of an Apple TV and then use AirPlay mirroring to display the content of your screen, of your iPhone screen on your Mac. So this is that, and now let's fire up Xcode and create a new game. So let's not select the single view application. Let's select a game, and we will call this Swift Jump. And also this is going to use, of course, Swift language. And the game technology that we're going to use is going to be Sprite Kit, not Scene Kit. And then we can click Next and create that on our desktop. And then let me just make this a little bigger. And we can jump right in here to our settings. This game only works in portrait, so let's disable landscape left and landscape right. And we actually also won't use the game scene here, since we want to do all of our game in code. We can simply delete that and move it to the trash. And then we can head directly for our game view controller, where we can also actually delete pretty much the complete content of our view.load and create some new code here. First of all, we want to create our view, our Sprite Kit view. So let's create that by calling it skView and making it the self.view and cast that to an skView, which is a view that lies in our storyboard, and this is going to be our Sprite Kit view. And what we want to do now is, after my beach ball disappears, is creating a scene, which is going to be a game scene. And as you can see here, we will get an initializer here only with a file name. And we will simply leave that empty for now, since we want to create another initializer. And then we will set the scene and its scale mode to aspect fit. And then we want to present our scene. So we use our skView and present the scene. And that's all there is to it. And now we can actually directly hit, as you can see here, there is a game scene class that we need to populate, and this is the scene we're talking about. And then let's also simply remove all of the content that's in here. We won't use did move to view. We can also delete touches began, or the contents of touches began, and then focus on our initializer method. So what we need is an init function, which will get a new parameter, which is going to be size, and the size is going to be a CG size object. We also need to override the existing init, and we will also use, since we created an additional init method or function, we have to create an init with coder, which is required. So this is required, and then we have to call super init with a coder and give it its decoder, and also let's call super init here, which is in this case with the size, and then pass along the size. And then first of all, what we can do here is setting a background color of our view, which is going to be or our game scene, which is going to be SK color, and we use a white color here. And then we will head to the top of our file and give it some properties. So let's begin by adding all of the properties that we're going to need for our game. So first of all, there's going to be a background, and this is going to be an SK node. Then we're going to have a midground, also an SK node. We will have a foreground as well, which is also an SK node. And later we will define a HUD so that we can display all of the necessary information to our player. Speaking of which, we will also create a player object, which is also an SK node. And also we will need a scale factor, which is a CG float, so that we can use our game on different screen sizes, also the iPhone 6 and 6 Plus. And then we will have a start button. So let's use also another node, which is a start button. and we will directly initialize that with sk sprite node and give it a image named, and this image is going to be called tab to start, which brings us to our image assets that we are going to use in a second. But let's finish by adding all of the properties that we're going to need for our game. We will also have an end of game position, which is at the moment 0, and we will load that from our plist that I've already shown you. And then we will also use a motion manager. And to use the motion or the accelerometer in the iPhone, we will have to import the core motion framework. So after we have this core motion framework imported, we can also create a motion manager. This can be a constant, so we have our motion manager and simply use cm motion manager here and initialize that. And then we will also use the a variable or a property to store the x acceleration. So let's create that property. X acceleration is going to be a CG float and initialize that with 0. And then we will have different labels for our HUD. So let's call this score label, and it's going to be an SK label node. And we will have a label for our flowers. So let's call that flower label, which is also going to be SK label node. And now there are only 2 properties left. So the first one is the player's max y value, which is going to be an integer. And last but not least, we need a flag to tell us when the game is over, and we will initialize that by setting it to false. And now that we have already used one of the images, what we want to do is opening up the assets folder here. We can delete this standard spaceship here. So let me quickly remove this item. And now we can add a new Sprite Atlas to our assets folder, which we will call assets, and then we will remove this already existing sprite and then add all of our assets to this new Sprite Atlas. And then we can later load all of the images that we want to see in our game from this atlas, which is faster than simply using images. And since we will only use our backgrounds once, we can directly drag them to our project, and we will make sure that copy items, if needed, is selected, and also add to targets is selected. So we'll then finish this, and then last but not least, let's also add our level plist to our project, and also make sure again that we have both selected copy items if needed and add to targets. And then we will click finish, and then we have our backgrounds, we have our assets, we have our level data, and then we can go on creating all of the necessary functions. And now that we have our properties ready, let's also make a new Swift class that will extend our game scene, and we will place all of the functions that will create game elements into this Swift file. So let's simply create a Swift file. Let's call it game elements, and then we import foundation here. Let's import Sprite Kit, and then we will simply make an extension of game scene. And this makes it possible that we can outsource a lot of code that we would have to write into our game scene class, so that we can put them in here. And this is a pretty good technique to keep your files and your code organized. But before we move to our game elements, let's go back to our game view controller, where we now can use our new initializer. And what we want to do here is, instead of using this empty initializer, we want to use our size, and we use the SK view and its bounds and its size to initialize our game scene class. Before we create the first elements of our game, like the background, let's go back to the game scene and first of all populate our scale factor, which should be our size and its width divided by 320 to accommodate for different screen sizes. And then we can move on and creating our first element, which is the background. And so that we have not so much code in our main game scene file, we will outsource that to our extension game scene. So let's create that function, call it create background. We won't use any parameters, but we want to return an SK node. And first of all, what we will need is a background node element, which is also an SK node, and we will need a constant for Y spacing. Since our different images do have a height of 64 pixels, we can use this value, let me go back, 64, and multiply it with our scale factor that we have just calculated. And to iterate through all the images that we have here, we will use a for loop. So let's create an index that has a range of 20. So let's go from 0 to 19. And then for each iteration, we will need a node. And this is going to be a SK Sprite node, and we can initialize that with image named. But if you have a look at the file name, as you can see, these images are named with 01, 02, and so on, and we can just use our index as to append that to the file name. We will use string with format and simply use background %, 0 to D, and as an argument we will use the index plus 1 to accommodate for the file name. And then finally we can set some properties like the scale factor, which is going to be the scale factor that we have already calculated. We can set an anchor point, which is going to be a CG point with an X value of 0.5, 0 value 0. And then also let's create a position for our different background elements. And the X position is actually pretty easy, so therefore we will simply position it in the center. So let's use self size width divided by 2. And the Y value is going to be our spacing constant here multiplied with the index of our loop. And since this is an integer and we create a CG point, we need to cast this index to a CG float in order for this to work. And then we can use our background node and add a child, which is a node, and then at the end we can simply return our background node, so that we can now, after creating this nice function, we can go back to our game scene, can go into our init function, and can now use our background property here, call the create background function once we built one time. So let's again use background, call create background, and then we can simply call add child background, and then we can run our application, and there we go. We have our nice background here, and once we have our player, we can also see how far it goes to the top end. We can see all of the elements that are placed in the backgrounds, in the different background files. So let's do the same with the midground. So we will head back to our game elements and create another function, which we will call create midground. Again, no parameters, but an SK node as return value. And again, we will create a midground node initialize it with skNode, and we will need an anchor, which is a CG point, and we will also need an X position, which will also give a CG float as type. Now, since we want to add about 10 of the clouds to the midground that we have in our asset, so let's have a look. We have a cloud left and we have a cloud for the right side. We want to determine randomly if we want to have it on the left or on the right. And we want to distribute these clouds along with our background. And to create 10 clouds, we will use a for loop with an index from 0 to 9, so that we get 10 iterations, and then we will use a sprite, or let's just call it name variable, which we will call name of type string, to determine which cloud we want to use. So either the cloud left or cloud right. And for our random number to be generated, let's create a random number, and we will simply use arg for random, and use modulo to create a random number. And if our random number is greater than 0, then what we want to do is not that. Let me just add the correct curly braces here, and then let's move down a little. And if we are greater than 0, then what we want to do is we want to use our name, set it to cloud left, and then in that case, if we have cloud left, we want to use our anchor, set this to CG point, X value 0, and a Y value 5, and then also let's give it an X position, which is in that case when it's left 0. And in the other case, the name is of course cloud right. The anchor sits at CG point. X value is going to be 1 in this case, and Y again 0.5 for the anchor, and the X position is going to be self and its size and its width. So in that case, we have a right cloud and we have a left cloud, and now all we need to do is creating a cloud node. So for every iteration, let's create a cloud node, which is going to be an SK Sprite node, and we will use image named, and therefore we have already generated our name variable. And then we can move on and give the cloud node an anchor point, which is our anchor. And last but not least, let's also give it its cloud position. So cloud node.position equals a CG point again. The X value is going to be the X position, and the Y value, let's say we will start at 500 and then add a CG floated index, because as I told you, we need to use CG float values for a CG point, and index is just an integer. And now that we have done all this, what we want to do is add our nodes to the midground node, so the cloud node. So let's say add child cloud node, and then we should be all right, and then we can return our midground node. Cool. Now let's head back to the game scene. We already have a background. Now let's use the midground, call create midground, and then again add child midground, and let's run this. And we actually should see one cloud, and there we are. We have two clouds here at a approximately the same position, which means that we probably did something wrong with the positioning. So let's go back to the game elements and then let's have a look. And indeed, we have told it to be 500 plus the index, but it should of course be 500 times the index. And then if we run our app again, we should only see one cloud, or actually distributed clouds, and this looks pretty nice to me. So let's move on and create our player. And to do so, we will add another function to our game elements extension. So let's call this one create player. Again, no parameters, but of course an Xcode as return value. And again, we need a player node, which is an Xcode. And then we will give it an initial position. So let's say player node.position equals a CG point, and we will position it in the center, so self.size.width divided by 2. And let's give an initial y value of 80. And then we'll also need a sprite for the player. So sk sprite node, and the image name is player. And then we can simply say player node add child, and then we will add our sprite. And there we go. And since we need some physics to apply to our player, so let's first of all, to get rid of this error, return our player node. We will now consider all of the physics. So let's give it a physics body. And to do so, we will use sk physics body and initialize it with a circle of radius. Since our player has an approximate shape of a circle, we can use this circle of radius to determine its physics body, and later also to decide how it will react to contacts and collisions. So we'll use our sprite and use its size and its width divided by 2 to get the radius. And then we will set the player node and its physics body and its dynamic value, first of all, to true. Later we will set this to false as a standard value, and later then activate it because we want our player to be affected by gravity, for example. But what we do not want our player to do is react on rotation or rotate when it hits something. So we will set allows rotation to false. All right. And since we're handling collision ourselves, we will give our player's node physics body no friction, no angular dampening, and no linear dampening. But what we want to do is give it a restitution, so that our body will not lose any of its momentum during collisions. So let's do that and use the player node and its physics body and its restitution and set this to 1. And let's use our player node, our physics body, friction, set this to 0. Now let me copy this. And we will now add angular dampening, set this to 0. And also the linear dampening, set this also to 0. And then let's do the following. Let's use again the physics body and uses precise collision detection, which we are going to implement in a second. And to do that, we will need bit masks to determine the different kinds of nodes that we're dealing with. And to do so, we will first of all create another class, which we will call, no, not a file, but a Cocoa class, generic node, which is first of all an NS object. And this node, which actually we can import Sprite Kit here, make it a subclass of skNode. But before we do anything else here, we want to create a structure for the different collision types. So we will have different collision bit masks here. And we want this first one to be static. The first one is the player, which is a uint33. Give that a value of 0x00. This is our first collision bit mask type. Then we have a flower later, also uint32. This is 1 bit shifted, so 0, 1, and static let. And we have a brick, also uint32, which is 0x02. And this should do it for now. We'll come back to this generic node later, and we will also create different subclasses of it for our flowers and for the platforms. But more of that later. So let's go back to our game elements, and let's handle some of these collision test stuff right now. So first of all, we set the player node and its physics body and its category bit mask to our collision bit mask. So let's first build collision bit mask type, which is player. And then we can next go to the physics body again and set collision bit mask to 0. Which means that we're telling Sprite Kit that we don't want the physics engine to simulate any collision for the player. And that's because we're going to handle those collisions ourselves. And now we will continue with the player node again. Player, here also player node, player node, and the physics body and the contact test bit mask. We are going to set this to collision bit mask flower, and of course also to collision bit mask brick, so that we collide with both these objects, flowers and bricks. And then we can return our player node, and let's build that, and our error should be gone. All right, so let's go back to our game scene and create our first player. But since it's neither going to be in the background nor in the midground, we need now to create a foreground. So let's use the foreground property and give it a new sk node to initialize it. And then we'll simply call sk add child and add our foreground here. And then we will use our player node and simply call create player. And then we will use our foreground and call add child player here. All right, so now it's time to have a look at our first player. And there it goes. You saw it for just a second, so let me go back to our game elements and set the physics body to false in its dynamic property to false, and then we should see it for a little longer. And there he is. And so that our player has something to do, we should give it a brick or a platform to stand on or to jump on, and we will simply add another function to allow us to create platforms at different positions. So let's say create platform at position, and then we will have to give that some parameters like a position where we want to place it, which is a CG point. And also we will need an off type property, so which is going to be type platform type, which we have to create in a second, and then we will return a platform node. And as you can see, we have a platform type and a platform node that we need to consider. So this is where this generic node comes into play. So what we want to do here is, first of all, create the platform type. So let's create an enumeration here, call this platform type. It's going to be of type integer, and then we have two cases here. We have normal brick, we'll give this value of 0, and a breakable brick, this is going to be 1. And then after we have defined a platform type, we should also define a new class for the platform node. So we have now a generic node, and we will also create a platform node. So platform node. Let's define it as a subclass of Xcode. At the moment, import Sprite Kit here, and then we want this to be a subclass of our generic node. And for the moment, we will simply keep this empty except for one property. Let's call this platform type, and this is going to be of the type of our enumeration platform type. So this is all we want to do here for the moment, since this is enough for our function here. And what's the problem there? Platform node, and well, let's see, platform node. And there we go. We're simply missing a return value here. So what we want to do when we create a platform, what we want to do here, first of all, again, is creating a node, which is of type platform node in this case. And then we'll need a position. So let's use a position constant here, which is going to be a CG point. The x value is going to be the position.x that we already have as a parameter, and we will then multiply this with the scale factor, and the y property is simply going to be the position.y. And then after we have this position created, we will add it as a position property to the node itself. So let's add the position here, position, and we will then give our platform a name. So this is simply going to be node.name, and this is going to be a platform node. All right, and then we will give this node a platform type, and this is going to be the type which we also received as a parameter. And then we need, of course, again, a sprite. So sk sprite node, it's going to be a variable, and then we have to check the type. If it's if it's simply a brick, then we will use sprite equals sk sprite node and initialize it. Let me give us some more space here. Well, let's say platform type, it's breaker normal brick, and is the correct type here. And then let's initialize it with image named, and this is simply platform. And in the other case, else, the sprite is going to be sk sprite node image name platform break. All right, and then we can use our node and add a child, and this is going to be the sprite. Very good. Now it's time to consider the physical behavior of our bricks. So what we want to do is access the physics body and initialize it with sk physics body. And since this time we're dealing with our platforms, we can use a rectangle of size, and then we will simply use the sprite and its size. All right, now what we want to do is again use the physics body and set its dynamic property to false, since we don't want it to react to the physics not dropping down and so on. And to make sure that our player reacts correctly, we have to set the category bit mask to the collision bit masked of type brick, we call it. And last but not least, we also need to use collision bit mask and set this to 0. And at the end, we can simply return our node. Here we go. And then we can go back to our game scene and think about our first platform. And therefore, we will create simply a platform constant, call create platform, add position, and we will create a CG point and set this to, let's say, 160 and 320, and it's the platform type normal brick. And then we will add our platform to our foreground. So foreground, add child platform, and then we will run our application, see what we've got here. All right, and there is our brick, which means we can now deal with our flowers. And as we did with the platform node, we will also create a flower. Let me zoom in a little. A flower node and create this one. And again, we will import Sprite Kit, make this a subclass of the generic node. We'll create an enumeration here for the flower type, also an integer. And then we have two types. We have a normal, let's do it uppercase, normal flower, which is going to be 0. And we have a special flower, which is going to be 1. And then again, for the flower type, let's create a property for flower type, which is of type flower type. All right, and then we can go back to our game elements and think about the new function which creates flowers, and we can actually completely copy this create platform at position and replace it with create flower at position. Again, we need a position as a parameter. We need a type, which is in this case a flower type, and we will return a flower node here. So then we will have to replace the flower node here. And then we will continue to make some minor adjustments, like again here, this is not a platform type, this is the flower type. Then we will have to rename this. It's not a platform node, it's a flower node. We have not a platform type here. Again, it's the flower type, and let's choose normal flower first. Let's have a look. It's called flower special and flower. So let's use flower here, and this is flower special. And then I think we're good to go, except that we don't use, let me just build that here. What's the problem? Expected. We forgot the curly brace here, and then everything seems to be all right. And here we do not use a rectangle, we again use a circle. So sk physics body, and then again we will use a circle of radius, and then we use the sprite, its size and its width, and divided by 2 to get the radius. And we then need to change the collision bit mask to a flower. All right, and then we have all set up to create our first flower. So let's go back to our game scene and create our first flower here. So let's create a flower, create flower at position. Let's make another CG point here. X, let's say 160 and 220, and we want this to be flower type special flower, and then we use the foreground, add child flower. All right, now we can run our app and see if there is a flower on the screen, and there we go. Now that all our game elements are in place, let's add some action and let's apply an impulse to our player as soon as we press or as soon as we click on our game surface. So let me zoom in a little, because we want to do this in our game scene class in the touches began function. And what we want to do here, first of all, is use the player's physics body and turn its dynamic property on so that it reacts to physics. And then again, we want to use the physics body and apply an impulse with a vector. And let's give this an x direction of 0 and a y direction of 20, so to give it a soft impulse. And there we go. When I now press on the screen, there it jumps a little. So this was the first step. Now let's move on by checking our generic node class, where we will add now two more functions. First of all, we want to create a function called collision with player, which is going to receive one parameter, which is an SK node for our player, and we will return a bool, which we'll later use for our HUD, and we will return false for now. And then what we can also do is add another function, call it check should remove a node, and there we will pass along another parameter with the player's y value. It's going to be a CG float. Won't return anything here, and then we will simply check if the player's y position is greater than the position of this node, so either a platform or a flower. So let's check the position of our node and add 300, and if the player is out of range of this particular node, then we want to remove it. So let's call self remove from parent. So now that we have the collision with player function in place, we can go to our flower node, override this function here, because we want to boost our player as soon as he touches a flower. So let's access our player, access its physics body and its velocity, and then apply a new vector with the player's physics body and its velocity. Let's unwrap this here, and its velocity and its y direction, and let's apply a new velocity and boost it up so that our player can hit the next target. And then later we will award some points for our high score and the score itself, and to tell our functions later that we need to update our HUD, we will return true here. And what we also can do is actually remove this star from parent. And as soon as our player hits a node, we want to do something else. We can also implement the collision with player function here, but in this case we only want to react if the player falls down, when he falls onto a node, onto a platform node. So what we check here is if the player and its physics body and its velocity in y direction is less than 0, so the player falls down, then we want to apply a new velocity. So again, the player, its physics body and its velocity is going to change. We apply a new vector. Again, we use the player and its physics body and its velocity and its x value for this vector. And we apply a new y velocity here by putting 250 into it. And then we need to decide if there is if this brick that we are currently falling onto is breakable. So we will check if the platform type is equal to platform type dot breakable brick. And if this is the case, what we want to do is remove ourselves from parent. And there are no awards for a collision with a brick or a platform. So what we want to do here is simply return false. But before we can see any action happening, we should first of all check again our collision our collision checks here so that our platform and our flower have the correct collision bit mask, and they don't. As you can see here, we have entered a contact test bit mask, which we will replace with a collision bit mask. Also here we will replace that with a collision bit mask, and then we should head right back to the game scene and adopt the SK physics contact delegate, and also at the bottom of our init function we should add a gravity to our world. So let's use the physics world and add some gravity, which is a vector, and it does not have an x direction, so let's set this to 0 and the y direction to -2, and the physics world also needs to be our contact delegate, so let's set this to self. Then we can go down a little and also add the delegate method did begin contact, and here we have to check which one of our objects, our nodes, so the platform, the flower, or the player is actually not the player, and then initiate the collision with player function. And to do that, we will create a, let's call this other node, which is going to be the SK node. And the other node we can determine by using the if statement. So we'll check if our contact and its body A and its node is not equal to the player, then this is our other node. So we can set this to contact body A dot node. And else, so if if the body A is our player, then we will set the other node to contact body B and its node. And that way we can determine which of the two nodes that participate in a contact or in a collision is not our player. And then we will use the other node, cast that to a generic node, and then call collision with player. And there we go. And to get everything going, what we need to do is to activate the dynamic property of our player. So let's set this to true, and also we want to give it a little boost so that he can make his first jump. So let's use the physics body and apply an impulse with a vector, nothing in x direction but 20 in y direction, and this should actually do it, and we can have a look and see what happens. So now I press on the screen, and there we go. The flower gave us a little boost, and now we just jump on our platform. And this is actually our foundation from where we will now, first of all, add the accelerometer, we will add a level data, and we will also then handle all of the stats like the score and how to calculate it and so on. So let's get going and add to our init function, let's add some code regarding our motion manager that we have already created as a property. So the motion manager, or didn't we call it motion manager? Let's go back. It's misspelled, so motion manager. And now let's use our motion manager and change the accelerometer update interval to 0.2. Then we can again use the our motion manager and call start accelerometer updates to Q, and then we will have the operation Q, which we'll have to define, which is the NS operation Q and the current Q, and then we have a simple handler which gives us some data, which are the accelerometer data, and then we also will have an error that we can use to check, but let's just use an if-let statement to access the accelerometer data and assign the data object to it. And if this works, let's use the acceleration and use acceleration data and the acceleration. Something seems to be wrong here because we have to unwrap the current queue. So again, let's check acceleration, and then we can add the acceleration to our x acceleration property, and therefore we will use a CG float of the acceleration and its x property and multiply it by 3/4, and then we will simply add to that self x acceleration times 0.25. Let's add some parentheses here, there, and then we're good to go. And now we have the acceleration data, and now we can use that data to position our player on the screen, and therefore we are going to use the did simulate physics function, or the did simulate physics delegate method. So did simulate physics, and then we can use our player, our physics body, and its velocity, and create a new vector which will, for the x direction of it, we will use the x acceleration and multiply it by 400, and then we will simply use the player and its physics body and its velocity and the y direction for this statement. And then what we also want to do is we want to check the bounds, so then that when we hit the left corner of our screen, that we reappear on the right edge of the screen. So we'll simply check if the player and its position and its x value is less than -20. Then we want to reposition the player and give it a new CG point, and the x value is going to be self.size.width plus 20, and the player's y position. And then we should also do an else-if statement and check if the player and its position and its x value is greater than self size width plus 20. Then we want to do the exact opposite. So again, player position, create a new CG point, and the x value then is going to be -20, and let's set the y value to player position dot y. And now we should actually run this on a real device. So let's give this a try. And there we go. I press on the screen, and let's move this a little around, and this works quite nicely. Okay, yes, that works. So I'm tilting my phone around, and our player appears and disappears. And now let's also check if he reappears when we move him too much to the left. So let's do that again, and here we go. Reappears on the other side. So this works very well, and that means that we can now add our complete level to the screen, and also add the movement, so that we move our game world up with the player. We'll start with adding the platforms to our game, and we should have a look at our plist file, which is called level01.plist, which contains all of the necessary data. So we will deal with end of level later, and we will focus on the platforms for now. And as you can see, platforms itself is a dictionary which contains the patterns as a dictionary and the positions as an array. And the positions array then again contains a dictionary that states both the pattern and the exact coordinates on where to begin. And the patterns dictionary contains a set of arrays which then again contains a dictionary with the type and the coordinates. So this is what we're going to use, but before we can do that, we will have to load this plist into our game. And since we only want to load this data once, and also we need a class that deals with our game stats and the score, we will create a new class. So let's click on App Delegate, select a Swift file, and call this Game Handler. And then we will create a class, call it Game Handler, and we will then add some properties already, like the score that we're going to use, which is going to be an integer. We will have a high score, also an integer, and we will have a variable for a property for our flowers that we collected, also an integer. And then, of course, we have the level data, which is going to be an NS dictionary. And then we want this to use a Singleton pattern, since we only want to create this one instance of this game handler class. So let's make sure to create a class variable, which we'll call shared instance, which is of the type game handler. And within it, we want to create a structure called Singleton. And within this Singleton structure, we create a static constant called instance, which is the game handler instance. And then we can return the Singleton and its instance. And then we will also need an init function. So first of all, what we should do is assign a value to score, high score, and also to our flowers. And since we can deal with this right now, we could also do it later first. But let's think about how to restore and how to save the high score and the amount of flowers we collected. We're going to use NSUser defaults, which are working like a persistent dictionary, where we can save tiny amounts of data like scores. And to access them, we create a user defaults object accessing the NSUser defaults, standard user defaults. And then we can access, we assume now that there is already data, because we can now use the high score and use our user defaults and access an integer for a key, assuming there is such a key, which we will what we will do in a second. So we will use high score here, and also for our flowers that we already collected, user defaults integer for key flowers. And to show you how to save data like this, we will create a function, call it save game stats, no parameters needed. And then again, we will check if the high score or the high score is actually the current score or the high score, so that we can determine if we have reached a higher score. And then we again use the user defaults, and it's user defaults, standard user defaults. And then instead of integer for key, what we want to do is use the user defaults and say set integer. And now we will use the high score for key high score. And again, user defaults, set integer, flowers for key flowers. And then after you did that, what you need to do is use your user defaults and tell them to synchronize. And then we have saved our game data. So much for that, but what we actually came here to do was loading our level data, and we will also do that in init. And let's first of all create a path. Let's do an if-let statement. If this path exists, so NS bundle, main bundle, path for resource. Our file is called level01. It's of type plist. And if this file exists, what we want to do is we want to check if there is level data, level let's call it level. And if there is and we can use NS dictionary and contents of file, which is path. All right. Then we can use our level data dictionary and assign our level. And there we go. We can build that. Should give us no errors. And the reason why we use an NS dictionary is that we can use this NS dictionary and its contents of file to load all of the information that is stored in our level 01 plist. So now that we have a way to get to our level data, we can go back to the game scene and go to our init function here, init with size. And let's do that right at the start of, or at the beginning here, and create a level data function. Use the game handler, not the level data function, level data constant. Use the game handler, its shared instance, and level data to access it. And now we can move on to the platform and actually remove the 2 lines of code that we wrote so far, since we need to expand that a little. And that means that we have to use our dictionary structure and first of all get our platforms. So we use the level data and access the platforms and cast them to an NS dictionary again. So within the platforms are platform patterns. So let's use the platform patterns here. Patterns, and therefore we need to use the platforms and access the patterns and cast them to an NS dictionary as well. And then within these platform patterns there is an array of dictionaries with the platform positions. So let's create platform positions, which is going to be platforms and the positions, and this has to be an array of NS dictionaries. And by iterating now through those platform positions, we can get all the data we need. So let's create a variable platform position in our array platform positions. And first of all, get the X and Y value. So let's use platform position and its X value. And there the float value. Let's do the same thing with the platform position and the Y value. Again, the float value of it. And then we can also use the pattern, which is the platform position and its pattern cast to an NS string. And now we can look up the pattern. So to do that, we will use a platform pattern. It's going to be platform patterns, and we access it with the pattern that we just got and cast that again to an array of NS dictionaries. And then we can iterate through the platform pattern. So let's use a platform point in the platform patterns array of dictionaries. So let's quickly remove the S here to spell everything correctly, and then we can get the X value here, which is then the platform point, the X key, and again the float value. Same for Y value, which is the platform point, and the Y value as float value. And then we need the type, which is going to be the platform, a cast to a platform type, where we will use a raw value for platform point access type, and then use the integer value for that. And with that, we have all of the data we need for the X value, Y value, and the type of our platform, whether it's breakable or not. And finally, we can create the correct position for each of our platforms by creating X position variable, and then we will simply use a CG float and use our X value and add our the X value that we got from the platform point and add the X value that we got from the platform position. So let's unwrap them, and then also let's do the same for, let me do it that way, Y value plus Y, and cast that to a CG float. All right. And with that information, we can now finally create a platform node object by creating it with our function that we earlier already used, and we can create a CG point with the X position, CG point with an X position and a Y position, and with the type that we just got from our file or from the dictionaries. And we also should unwrap this here. And then we can access the foreground and add a child, which is called platform node. And then let's see what's wrong here. Use of unresolved identifier. So let's use that correctly. Exposition. So there is an I missing here. Okay, so now build that again. And that works. And now let's see, we can do that in the simulator for now again. And now look at that. There is our first set of bricks. Isn't that cool? Since it's pretty boring to do actually the same complicated stuff over and over again, let me just copy and paste this same procedure for the flowers for you. So we'll again remove these two lines that we have created earlier for the flowers, and then instead add the same code with the difference of using the flowers, but the pattern is exactly the same. So you can simply always replace platform with flower in that case. So let's have a quick look again and see if we have flowers, and there we go. Isn't that really cool? We have our flower patterns here, and now all there's left to do actually is moving up together with our character. And to do that, we will move down a little to our update function, and there we will actually do all of that code. So let me zoom in a little and give us a little more space here. And what we need to do here is change the position of all three elements: the background, the midground, and the foreground. So we will check if the player and its position and its Y position is greater than 200. Then what we want to do is move the background and its position. So let's create a new CG point. We don't want to move it in X direction, but definitely in Y direction. So let's use negative player and its position and its Y position, and subtract 200. And to get this parallax effect, we will divide the background by 10, the midground by 4, and use the plain value for the foreground, so that we have different speeds for each element in our game. So let's divide that by 10. Now let's use the midground and its position, new CG point. Again, X value is at 0, and then move it up here, position dot y minus 200, and this time divided by 4, and here the foreground and its position, and create a new CG point, again 0 and minus player position y minus 200. Okay. Now that this is done, we could also handle removing the unused elements, or the elements that do not matter anymore. And for that, we will simply use the foreground and enumerate child nodes with name, and we have the platform node, and then we can use a block with node and stop. Don't need to do anything fancy here, and then can create a platform, use the node, cast that to a platform node, and then simply call platform check platform. Where's the problem here? Platform. How did we call that function? We called it should remove node. All right, so let's go back and then call should remove node, and give this the position of self player position y. And then let's also do the same thing again with the foreground, enumerate child nodes, this time with the flower node, and again node and stop. And this time let's create a flower node as flower node, and then use the flower and should remove node self player and the position and its y position. And with that, we're removing the objects. We are also what's the problem here? We should also actually move along, and I think, did we forget? Yes, we forgot a parentheses. So now let me run this again in on a real device. So let's see what happens. And there we go, there's our game, and I press to start, and as you can see, we're moving around quite nicely, and everything moves. And let's see, I missed that brick, but we can actually jump on that one, it disappears, and we can move on and move on and move on, and everything moves with us, the foreground, midground, and background. This creates this nice effect. So let me go to the top, and then we will see what we're still missing. So we can move and move and move, and now we actually won. And as you can see, also our old flowers are gone. So when we travel all the way back down, there we go, we can see that we have now reached the bottom of the screen, and the problem is now that we cannot restart the game. So we will add this logic as the next part of our game. Let's now move on, and let's start with the reset of our game. We will create a new property for this. Let's call it current max y position, which is going to be an integer. And in our init function, let's say after we have set the background color, let's set this current max y to 80, which is our initial position. Let's also use our game handler and use the shared instance and set the score to 0. And let's also set the game over flag to false. Then what we should also do is define the end of game position, which we will get by accessing the level data. So let's bring this up a little. the level data and put it right below the background color. And then let's use the level data and then just copy the key, which is end of level. And then we use end of level here. And then we use the integer value of it, and let's explicitly unwrap this. All right, and what we should also do then is unwrap the level data, and then this should work. And next we should add our start button, so let's do that. So let's use the start button and give it a position, which is going to be a CG point. The X position is going to be self size width divided by 2. So let's position that in the center, and let's say at about 180 in Y direction. And then let's maybe right on the top of our start button, let's also use our HUD and create a new SK node and add this as a child. The HUD, we should do that. Actually, let's cut this out, move that up a little. Also, let's move that up a little, and then the HUD should be in front of the foreground. So let's add that right here, and then we can use the HUD and also add the start button to our HUD. And for the rest of the HUD, we will come to that later. So for now, we are going to move on to our start button, and we will scroll down to the touches begin and delegate method. And what we want to do is we want to check if the player's physics body is already dynamic. And if this is the case, we are actually playing the game, and we can return and no longer perform this function. So we will ignore everything that is below here, and only one time we want to call all of this. So applying the impulse, setting it dynamic, and also remove the start button from parent so that we get rid of it. And now let's see, we can do that in the simulator if this works so far. So if everything works nicely, then there is our start button, and we can press start and it disappears, and we continue playing. All right. So that you don't get bored, I'm going to insert now the code that we're going to need for our HUD, which I'm going to insert right below we add the start button. So this is what it looks like. We're simply creating a flower to indicate how many flowers we've collected, initialize the flower label with the font, give it a font size, color, positioning it, and that's it actually. And also we get the flowers that we already collected from our shared instance and the flowers. And then we do the same thing with the score label. So there's nothing fancy here. And what we want to do now is actually go back to did begin contact and actually decide how to give our player the points he deserves regarding which kind of flower he touched, whether it's the yellow ordinary ones or the special, no, it's the other way around, the ordinary white ones or the special yellow ones. So to do that, we can actually remove this line of code here and create a variable here at the top, which we will call update HUD, set it to false, and then we will use the update HUD variable here and use then our other node and call collision, which we have to cast still to a generic node. Then we can simply call collision with player again, and since this function returns either true or false, we can determine if we have to update the HUD. And if this is the case, so if we have to update the HUD, Then what we want to do is our flower label and its text property is going to be set to a new string, which is going to be some white spaces, and then we will simply insert the game handler and its shared instance and the flowers, and we will do the same thing for the score label and its text, and insert a white space. Oh, we don't need a white space here. And then insert game handler, shared instance, and the score. And thereby we are updating our score so that this also takes place. Let's go into our flower node and make some changes here. Since we did not account for our game handler here, what we want to do after or before we remove our flower from the screen, we want to use the game handler and its shared instance and the score, and add some points. And the simplest way to do that in one line is we use our flower type that we have here as a property, and if this is equal to flower type normal flower, then what we want to do, so this question mark indicates then, should that do that here, then we want to give the player 20 points, and the column here represents else. We want to give it 100 points, so the yellow ones give the player 100 points. And then let's do the same thing for the flowers. So let's add, if the flower type is equal to flower type normal flower, then we want to give our player 1 point, and if it's a special one, 5 flowers. And then we do simply the rest, remove from parent, and by returning true, we indicate that we want to update our HUD. So let's return back to our game scene and to the update function, where we will now also focus on awarding points depending on the distance we traveled on the screen. So we want to check if the player and its position and its Y value, so the Y, the height actually of the traveled space, we have to cast that to an int to compare it to the current max Y, so to what we actually traveled so far as a maximum. And if it is greater, what we want to do is we want to use our game handler, its shared instance, and the score, and add the difference between our current position and the last max Y position, so, or the last current max Y. So what we want to do is again use an integer and cast our player and its position and its Y value to that integer, and then create a difference between the current max Y. And then we want to assign a new current max Y position, which is the current player position, so player position dot Y. And once we did that, we can use our score label and its text property and simply assign the new score value, so game handler, shared instance, and the score. And that's it. And then what we also have to do is we need to check if the game, well, if it ended. And we can do that by, again, using the player's position as an integer and the position and Y, and check if it's greater than end of game position. And if this is the case, we want to call a function that we will call endgame. And we will also call endgame if the player fell too far down. So we will check if the integer, again, player and position and Y, is less than the current max Y minus 800. So as soon as the player falls too much, we will end the game, which means that we have to create a function called endgame, so function endgame. And what we want to do here is, first of all, set our game over flag to true, and then we will save our game. So let's use shared instance, and then let's use the shared instance and then save the game stats. And then we want to create a transition to another game scene, the end game scene. So let's call this transition, which is going to be an SK transition. Let's say a fade with duration of 0.5 seconds. And then we will call this end game scene. And then let's use it end game. You will get this as a tutorial file. So end game with the size of self.size. Let's just quickly finish that, and then we'll use self.view and then present scene end game scene with the transition. And well, to finish this, let's add the end game scene from the game data. So let's just move that around and place it right below the game scene, and make sure that copy items if needed and add to targets is selected. And there we go. As you can see, again, nothing fancy here, just definition of a flower again, the flower label, positioning, size, color, and so on, and accessing our game handler to access the number of flowers and so on. So really nothing fancy. And at the end, a touch as began function so that we can transition back to our game. So what we really need to do now is go back to the game scene. You already know game over is true. We have transitioned to here, and the last step we need to do here is, once our game is over, we do no longer want to update anything. So let's check if game over, that we simply call return, so that nothing at the bottom of this really happens. And now it's actually time to run our game and see what happens. So here's our game. We have our start button, and I press start, and there you go. You see our HUD, you see how the points get awarded, you see how we collect the flowers, and we move up and up and up and up, and there we go. And now we have to finish this, so I better be good. So I'm collecting and collecting and jumping on the bricks, and as you can see, jumping on a brick doesn't give you points, only going upwards gives you a higher score, and also collecting these flowers. And now we end it, and there we go with this. The upper number is our high score, and we play again. And there we go. And now let me just end this. So I have to drop down, which is quite hard. And as you can see, we still have our high score at the top, and we have 2,312 points, and we can tap to play again. And this is our game, and this is really cool. And we did this in a bit more than an hour, 1.5 hours. And you can expand this with more levels, add some sound effects, and whatever you like. So have fun creating this app, and also don't forget to comment below with ideas for next year to win all of the Udemy courses, and you also get the newest course to create an app from scratch for just $20. So thanks for watching, and see you next year.